So as far as the homogeneous equations are concerned, what you will have out there is that, let's say if your derivative expression is basically can be expressed as a function of y or x. That is what is a homogeneous equation. Now, what is really I observe as a teacher is that if you look at the the combined powers of a particular term in the given expression, if it is constant throughout, then we call it as a homogeneous equation. So if I look at here, the power of x is 1 and here it is y is 1. So 1 plus 1 is 2. And that's your combined power is x squared. And similarly, here is y squared and x squared. So this is homogeneous equation. Now I can give you another example. Now let's say if you have got dy by dx is, let's say, x cubed plus 7x squared y minus 8y cubed over x to the power 3 plus y to the power 3. Now if you notice here that every term that we got is having a degree 3, and that's where you say, okay, it is a homogeneous equation. Now the interesting part out here is that if I wish to express this as a function of y over x, if I divide numerator and denominator by x cubed, for example, if I divide numerator and denominator by x cubed, might this become 1, 7x squared y will become 7 times y over x, minus 8y cubed over x cubed. I'm actually dividing both numerator and denominator by x cubed. So over, now if I divide this by x cubed and x cubed get cancelled, so I get 1, and y cubed, this is y over x the whole cube. So you can see that I could write down the derivative expression as a function of y over x, as a function of y over x everywhere. So this is why we call it as a homogeneous equation. Now, what's the strategy to solve these kind of questions? Like when you're solving a differential equation, you have to substitute. Let's say I can take y equals to vx. This is the specific substitution you make. Now, I would recommend, if you can remember this, that will help you to be quick in substitution and doing the question. Now, what you do, the next step is that if I got, I'm substituting y equals to vx, where v is a variable, x is a variable, and y is a variable. So all three of them are variables. So dy by dx is actually, or you can say, in this case, it will be x times dv by dx plus v. So this is the general expression that I again recommend to remember, that can be straight away used to replace dy by dx. Now, when I do that, what happens is that, assume this is my question that I'm solving. So instead of dy by dx, if I put v plus x dv by dx is equals to x times y is nothing but vx, since I've taken y, is vx plus y square over x square. So when you take v square, x square common, actually you get v plus v square. So x square, if you take common from here, actually it is like this: x square v plus v square over x square. So this get cancelled, and as a result you get v plus v square. Now left hand side is also v plus x dv by dx. So one of the v get cancelled, and now we come to a stage where you got to apply once again the separation of variables. So here we go. So if I come to this step, my dv by v square equals to dx by x. Now you got to integrate both the sides. Now when I integrate both the sides, what we get is this step. So the integration of dx over x is ln absolute value of x. The integration of this is, you can take it as v to the power negative 2, and if you integrate that, you get this step. So instead of taking c, if you take ln c, that helps you get rid of ln easily, and you eventually get this as answer. So if you, wherever you got the v, you can replace. So v is y, y is vx, and so v is y over x. So that's what has been substituted here, and you get the expression purely in terms of x and y once again. So this is one of the example. Let's take one more example on the homogeneous equation. So in this example, what we have is, let's say, y square minus x square over 2xy. Now, how do I know whether this is firstly homogeneous equation or not? So in this case, if you look at the degrees of each term, I combine them and they are all 2. So that's why it is a homogeneous equation. So the substitutions are pretty common. Y equals to vx, and the substitution for dy by dx, you replace this by product rule here, v times dt dv by dx, x times dv by dx plus v, which is the derivative of like vu dash plus uv dash we are doing. And so that comes out here in place of dy by dx. And in place of this, you substitute v square x square minus x square. So this is v square x square minus x square or 2x times vx. So x square get cancelled. Now, if you bring then v this side, what you get is v square minus 1 over 2v. And if you take LCM, you get v square minus 1 minus 2v square. So if you simplify that, you get this. Now, the next step is to isolate the variables. So if I isolate the variables, you get 2v over 1 plus v squared dv is minus dx upon x. So when you integrate this, this is by substitution. This you go do by substitution, which is ln 1 plus v square equals to minus ln absolute value of x plus ln c. So, and then you get rid of the ln term, which is going to give you this as a final answer. So after this step, once integrate, this is a substitution, which I showed earlier. So it is f dash x over fx format. You can remember that way. So it is straight away ln 1 plus v square. And when you get rid of the v term, which is, you can replace y by x, and you simplify to get the expression. So this is how you use the homogeneous technique to solve the differential equations.